So what's the real difference between just, mixing a couple of things together versus making something totally brand new? It sounds kind of simple, right? But today, we're going to see how just a little bit of heat can be the decider between a simple separation and a full-blown chemical reaction. Okay, so let's set the stage. Our little experiment here kicks off with two simple ingredients. We've got some fine gray iron filings and this bright yellow sulfur powder. We just pour them into a test tube and give them a good stir. So, what did we actually just make? Are they one new thing, or are they just really, really close neighbors? Right now, it's just what scientists would call a mixture. That's it. The iron is still iron, the sulfur is still sulfur. Nothing's really changed their identity. But how do we know? I mean, how can we prove that they haven't really combined to become something else? And that is the million-dollar question. I mean, if they're still just two different things hanging out together, we should be able to pull them apart again, yeah? So let's think. What's special about iron? What's special about sulfur? What properties can we use to our advantage here?
Okay, here's the big clue. Iron, well, you probably know this, it's magnetic. Sulfur, on the other hand, a magnet doesn't do a thing to it. And that's the whole key here. In a simple mixture, everything hangs on to its original superpowers, you could say. And here we see the plan in action. You bring a magnet up to the mixture and, would you look at that? The magnet just yanks those gray iron filings right out, leaving all the yellow sulfur behind. Works like a charm. We've separated them.
What we just did is a perfect example of what's called a physical separation. We used a physical property, in this case, magnetism, to separate the parts of our mixture. We didn't change them chemically at all. We got our iron back and we got our sulfur back, totally unchanged.
Okay, that was pretty straightforward, right? But things are about to get a lot more interesting. What happens if we stop just mixing and instead we introduce a little bit of energy? What if we add some heat?
Whoa, okay, now things are getting wild. As you can see here, when we heat up that test tube, something amazing happens. The mixture starts to glow, like super bright all by itself. That glow is basically a giant sign that says, hey, I'm not a simple mixture anymore. A real transformation is happening.
And that's it. That is a chemical reaction. The heat we added, that was just the little push it needed, the activation energy, to kickstart a process that totally rewrites the rules for our ingredients. The iron and sulfur atoms are actually breaking apart and reforming into something new.
So once the light shows over and everything cools back down, we don't have a powder anymore. What we have now is this hard, dark, brittle lump. This is a brand new substance called iron sulfide. It doesn't look like iron, doesn't look like sulfur, because it's not.
But hey, how can we be absolutely sure? Let's be good scientists and repeat our test. If it was just a mixture, our magnet trick should still work, right? So let's bring back the magnet.
And here it is, the moment of truth, shown side by side. On the left, the magnet pulls the iron out of the powder, no problem. But on the right, when we bring that same magnet up to our new dark lump, nothing happens. I mean, zero, zilch, nada. The magnet has no effect on it. And that, my friends, is the heart of a chemical reaction. The iron's still in there, sure, but it's now chemically locked arm in arm with the sulfur. It's not free iron anymore, so it's lost that magnetic property. We've made a totally new substance with its own completely new set of properties.
Hey, remember that crazy intense glow from before? Well, that's another huge clue. Chemical reactions always involve a change in energy. As this diagram kind of shows, once we gave it that little nudge with the flame, the reaction itself started giving off its own energy in the form of all that heat and light. That's where the glow came from.
All right, so let's put it all together, head to head. In the mixture, our iron and sulfur were just hanging out. They kept their own identities, and we could easily separate them. But with the compound, we made something totally new, iron sulfide. It has different properties, and those original parts are now chemically locked together.
You know, the magnet trick is cool, but let's be real. It only works if you've got something magnetic, right? Physical separation is a huge field, though, with all sorts of clever ways to pull mixtures apart based on their different properties. I mean, think about it. You want to get sand out of water? Just let the heavy sand sink and pour the water off, or use a filter. Trying to separate alcohol from water, you can boil them. It's called distillation, because they have different boiling points. Heck, you can even separate the different gases in the air we're breathing right now using a super cold version of the same idea. Okay, so let's boil it all down to the main takeaway. A physical change, like our magnet separation, just moves things around. No new substances are made. But a chemical change, a reaction, that's a total transformation. It makes brand new things with brand new properties, and it always involves a change in energy.
Which brings me to a final thought for you. Next time you're making breakfast, think about this. You crack an egg into a hot pan, that clear, goopy stuff turns solid and white, and you can't turn it back just by cooling it down. So, based on what we've just seen, what do you think is going on there? Is that a physical change, or is it a true chemical reaction?